Hey guys, welcome back, and in this lesson we will design the floor and the house for scene. So I'm in the same project, and first of all let me just clean the project a bit so we can start working on the actual scene. And alright, so let me just change the colors so that it mimics the actual scene. So I have copied the color from my previous project and I will just use it over here, and I will just provide some camera properties as well. So let me just position the camera somewhere. Alright, and let me just set the near value and the far value. So these two parameters will define what should actually render in our particular scene, and anything below 0.1 unit will not be considered in the render, and anything far away from 100 units will not be considered in our render. Alright, so let me just add a floor now, so we can create a function floor, and it will return the mesh, and as the floor is just a plane, so we will use the plane geometry. And same, we will use the mesh standard material for that, and let's give it a color of, this should be something near to the green, and let's just scale the plane geometry to some unit. So let's provide it 20 by 20. And if you are wondering how can we identify or see like which argument should be provided over here, or what does it mean over here, so this array is simply passed on to a native 3 geometry object. So if you want to see what are the arguments for plane geometry, then we can go simply to ThreeJS.org, and here we will find the plane geometry and see the arguments for it and for its constructor. So let me just search for plane geometry, and here you can see these are the two arguments that we have passed on from over here as an array, and these are actually the width and height of the geometry. So alright, so it should create a plane inside our scene, so let's just import that over here. Cool, so we can now see our plane over here, and we actually want to rotate it so that it is completely horizontal. For that, let me just go through some drawings to understand the actual values of rotation. So currently we have drawn the floor, and it is appearing something like this. And let me just draw the axis over here. Alright, so for future references we have a 0 degree over here. Let's assume this is a Cartesian plane, and here we have 180 degree, this is 90 degree, and in terms of pi we have 0 degree over here, and 180 degree is equal to 1 pi, and similarly 2 pi will equal to 360 degree. So currently the plane is appearing in a vertical direction, and what we want to do is to rotate this plane by 90 degree. So 90 degree would be equal to half of the pi, which means we will need to multiply the pi by 0.5. So what we can do is go to the mesh of the floor and apply rotation over there, and we need to apply the rotation in the first axis, and that is mat.pi into 0.5, and the rest of the axis will remain the same. So it will just rotate the plane to be completely horizontal. Perfect. So what we now need to do is to add a house in the center of the screen. So for that, let's create another component, let's name it walls, and let's return a mesh. So we can actually create 4 different planes and form a square shaped house, but for simplicity we can simply use the box buffer geometry and design the base of the house. So let's use the box geometry and let's give it an arguments of, let's say, 4 4 4, and let's give it a mesh standard material and give it a color of pure white. Let's use the walls inside our canvas so we can see what's going on. Perfect. So alright, so right now it is appearing at the center of the screen. So what we need to do is to push the box in the Z direction. So I assume this is the Z direction. So what we can do is try something over there. So we can change the position of the mesh, and here we want in the X direction it should be 0, and I assume it's the second argument is the Y direction and the third is the Z. So let's change it in Z direction, and assuming that Z is in going up upward. So let's test it out. Alright, so Z is moving in this direction, so let's try the Y direction. You can reset this to 0 and change this to 2. Perfect. So actually Y is the direction that is moving in upward direction, like it is the vertical axis. So we actually provided 2, which is half of the height of the box, and let's provide it or convert it to variable. So we can say const wall height equal to 4, and here we will provide the wall height, and this will be wall height divided by 2. Perfect. So we can now increase the height directly by changing this variable, and it should actually work. Perfect. Alright, so we have designed the floor and the walls. We now need to add the roof. So for that, let's create a new component, and this is the cool thing about React 3 Fiber, like we can design components for or create components for individual meshes, and we can control them individually. So let's create roof, and let's return a mesh. We will use the cone buffer geometry or cone geometry for this, so it can have cone like shape of roof. You can use anything you want. So let's create a cone geometry and provide arguments of, you can play with different arguments, but I'm just copying the values from my previous project so that we can quickly iterate over it. But the procedure is exactly the same. We search for cone geometry inside the documentation of ThreeJS, and it will tell us what the actual arguments are and how we can configure them, or we can actually provide different values over here and then use the values from, or copy the values from here. So here we have the first argument is the radius, the second is the height, and the third one is the radial segments. So I will use some values from my previous project. So I put 3.5, 1 and 4, and let's provide a mesh standard material and provide it a color, this. Let's use the roof inside our canvas, and nothing appears. So what am I missing over here? Oh, it actually appears on the center of the screen, so we need to move it upwards. And by now you can identify like the height of the box is equal to wall height, so we need to move or position the cone or the roof in vertical direction by wall height amount. So we can say position is equal to 0, wall height 0. Perfect. And what we now need to do is add another extra height equal to the height of the cone. So let's add that, or I think by half, 0.5. Yeah, this looks good. And let's convert this to variable as well. So roof height is equal to 1. We will change the room height over here and provide a dynamic variable value over here. Yeah, this should just work. And we now need to apply some rotation so that it is exactly aligned with the height of the walls. So for that, let me just see how much we want to rotate this. So I think this is exactly 45 degree, and by looking into the same diagram that we discussed previously, we need to rotate this over here, which is half of 90 degree. So it is exactly pi by 4. So this one was pi by 2. This angle is pi by 4. So what we need to do is apply some rotation on the roof. So let's give it a rotation, and it should be minus mat.pi into 0.25, 0 and 0, and the direction of rotation is wrong, so let's change the variable to another axis. Let me just think. This one is y-axis, and yeah, we need to do the rotation on the y-axis over here. Perfect. So our nice little house is ready. Alright, so the final thing that's remaining inside the house is the door. So let's create the door component and use it inside our canvas. So it will return a mesh. And we will use a plane geometry for the mesh. So we will provide a plane geometry, and the arguments will be 2.2 for width and height, and for width and height segments we will provide a value of 100, so it can have a lot of triangles, you can say, while drawing this particular road. And this will be effective when we provide a texture to this door later on. So you can leave it as a default for now and change it later, it's up to you. And for material, we will use the same mesh standard material and provide a color of red. And let's just use the door inside the canvas to see where it renders. And yeah, perfect. So the door is now rendering at the 0, 0 of the scene, and we need to move the door inside the z-axis, which is pointing towards us. Like from here it is pointing towards us, so we will push this mesh in the z direction, position 0, 0, and here it will be wall height divided by 2. Perfect. And we'll talk about this issue in a bit. So let's fix the height of the door, and it will be half the width and height of the plane geometry, so it will be 1.1. And what we need to do is add 1.1 to the position y. Perfect. So the issue that's happening over here is called Z fighting, and which means that when this particular scene is sent to the WebGL render for rendering the pixels, then the renderer can't identify which pixel is appearing behind another. So while rendering the wall of the house and the door, it can't identify either the door should come first or the wall should come first, because both of these pixels have the same value. So to fix this, we need to push the door slightly away from the wall, and we will add 0.001, a small delta, to the position Z of the door, and it should fix it. Perfect. So now the basic model is complete, and we will, let's increase this. As I can see, it still has some flickering. Yeah, it looks good now. Alright, so the basic scene is complete, and in the following lesson we will add some graves and some dark theme to the whole scene. Alright, I hope this helps, and thank you for watching.